Okay, cool. Today we're going to talk about real-time web applications. Let's just go ahead and get started. Everyone knows what a server is by now? I hope after this assignment, right? So a server is nothing other than a machine that services requests. WebSockets are a slightly different paradigm than what we've been. So WebSockets allow two different machines to communicate with each other over the internet or over the web. When typically developers talk about WebSockets, though, they're talking about real-time communication, and what that means is that instead of having this traditional HTTP request-response flow, we can actually send bidirectional messages. So I'll talk about what that is in just a second. But WebSockets themselves are just basically ports on your computer that can service requests over the internet. That's all that's happening there. Okay. So when we're talking about HTTP, like I mentioned, right, every request has an associated response. If you send a request to a server, the server must respond with a response if the server exists. And also, servers cannot send data to any client without the client first sending a request to the server. Does that make sense? The client must initiate the sequence of data flow, right? Everyone understands that, right? There's no way your server can communicate to a client without the client initially sending a request. WebSockets are a little bit different. So it starts out the same way that the client sends a request to the server, but the client basically first says hey, I exist. The server says, I acknowledge your existence. I'm going to open a connection with you. Now, this opening of a connection over WebSockets is kind of interesting in that now we can actually send bidirectional messages between the server and the client, which means the client can send data to the server whenever it wants, and the server can send data to the client whenever it wants. So this opens up a whole host of new types of applications. For example, messaging, right? Like a chat application. Chat applications are inherently real time in the sense that, let's say we have a bunch of different clients, and then we just have one server, and the clients are not connected to each other except through the server. So when a client sends a new message, it goes to the server, but the server then needs to relay that message to everyone. But notice that under just typical HTTP, the only way that this client could get that message is by continuously asking the server, hey, do I have new messages? Do I have new messages? Do I have new messages? Right? Which is a lot of load on the network, which you might not want if you're running a service like Facebook. So instead, what we can do now is open up a WebSocket connection between these two, so the server can actually just send a request straight to the client whenever, or server can send data to the client whenever that client has messages waiting for it. Does that make sense? Okay. And then the moment either side of it closes the channel, then the connection is terminated. Okay. Yeah, I think the last lecturer or before me, his name was Abhinav, who's really into open source development, so he contribute to a bunch of random projects. But it is the power of open source is pretty amazing in that people there's a lot of companies who rely on fully open source code to run their entire business, and that open source code allows us to actually teach very, very sophisticated technologies to everyone else because it is open source. I think that was his main message. Any questions about open source? All right. Once you guys are good enough, you should all contribute to open source. If you're not good enough, then you'll get roasted, and then you'll probably stop, which is what happened to me. All right. Socket.io is an open source package. It's been around for quite a few years. It basically is a wrapper around the underlying WebSocket protocol that exists on node servers as well as on your local machines. So you know how I showed you HTTP, basically whatever letters come before the : / specifies a protocol over which you're communicating. WebSockets actually have their own protocol, which is WS : / So this is the WebSocket protocol. But Socket.io basically says, okay, working with a WebSocket protocol is actually quite complex, and there's a lot of moving parts, and you can get really deep into the dirt. But for most situations, all we need is the ability for clients to easily send messages to a server in a reliable way, and for servers to send messages to clients in a reliable way. So Socket.io is essentially a library that helps us do that. Yeah. Socket.io enables real-time bidirectional event-based communication. That's basically exactly what I said. And what we're going to do today, and today I think it's actually going to be a shorter lecture. I would be so surprised, again, if this one runs over. But, actually just so surprised. It would be insane. All right. So, like I mentioned before, Node under the hood already has server capabilities, right? Express is nothing other than a library that wraps around the pre-existing server capabilities of Node and creates an interface that's really easy for developers to use. That's like the whole point of Express. So I think it's important though for everyone to know just like what does a bare bones HTTP server look like when you're just using Node. So at the top you see like var HTTP equals require HTTP. This HTTP module is actually something that is already included with like every Node distribution. Like you don't need to npm install HTTP to have access to this package. So now when you see like the second line is a request listener, which basically takes a request and response object, and given the request, which includes like whatever the request URL was, you need to construct like the appropriate response. Express's wrapper around this is it says like, okay, I'm going to separate out all of the within here you could have had if route is equal to / then send this response. If route is equal to this and method is equal to this, then send this. Express basically says, okay, instead of having this like stupid if block that would be like quite long, let's just like change these into different function handlers. So that's when you get app.get, whatever the route name is, app.post, whatever the route name is. Essentially, those are constructing an if block in the background into this function. Does that make sense? And that app object is nothing other than this if block. So what we could do is actually just replace a request listener with app. Does that kind of make sense? Okay. That's basically like how it works. So anyways, you can create a server by providing the request listener as an argument to this function, and then you can just run the listen command just like you can in app, which is just going to like start listening on some port. Now with Socket.io, Socket.io actually needs to directly operate over the underlying Node HTTP server, and it doesn't work immediately with Express. So Socket.io is built on top of Node. It's not built on top of Express, which is built on top of Node. Does that make sense? Like Socket.io, when they develop Socket.io, they have no idea of the existence of Express as a framework. So we need to make sure that both of these packages can work with each other in like a very seamless way, which there is a very easy way, which I'll show you in just a second. But let's say we don't have Express at all, and we're just writing a bare bones HTTP server. I think we can read this code. The only real change is that we're requiring this package called Socket.io, and then we're at the very end, the socket server, which is basically processing requests over the WebSocket protocol, is just initialized by running the function that is imported from the Socket.io package with the server as an argument to it. Any immediate questions? Okay. This will make sense when we start like programming a little bit. Okay. So like I mentioned, the very first thing that happens in this diagram is the client sends a request to the server, a request like for a connection. You can call this event like a connection. What this bit of code is just saying is that, and first note that this is server code. So before, right, we have this var socket server is equal to IO HTTP server. This is on our Node server. This is not on the client side. When you're dealing with WebSockets, it becomes a little complicated because there's a server socket and a client socket that are talking to each other. So it's important to distinguish what pieces of code are where. So when a client connects to the server socket, we are able to run this function, which we provide, right? It's just like a callback like we've seen before. And we get access to this socket object. So kind of the flow of things that happens is first like the client connects. And then what happens is a socket object is created for the client on the server side. So that object basically exists in memory. It's like a way to identify, it's a way for the server to know who is talking to it at any point in time, right? Because we might have several different clients. So the moment a client connects, pretend that client gets a unique identifier that's associated with the IP address that request is coming from. And then an object is created in memory on the server side that is unique to that client. That's what this object is. That's provided as a parameter to that function. Does that make sense?
Does that have to do with cookies?
No. Because over the WebSocket protocol, I don't think, I erased it, but over the WebSocket protocol, I don't think cookies are sent in headers. But they might be. I think it has to do with like IP addresses. I think that's how they do it. Maybe they use cookies. I don't know. I want to look into that. Okay, I'll look into that later. Yeah. Does that make sense so far? So this socket object represents the client from the server's perspective. Socket server is the web socket that's listening on the server side. Okay. Now we're jumping into client-side code, right? Like HTML only makes sense for client-side code. So now we look on the client side. We want to do a few things. First is we want to require, right, or import or get the file that allows us to actually connect to the server socket. So Socket.io has two distributions. It has one server distribution, which is what we just saw, right, when you do require Socket.io. And then it also has a client-side distribution, which we can get from a CDN. So everyone kind of remembers that CDN.js website I showed you guys a while ago. So we'll use that again today to get the Socket.io distribution. Once we have this client distribution, we can actually just write client code, assuming that the variables that came in from that top JavaScript file are available to us. So in particular, those include this variable or this function called IO. This IO is different than the socket server IO constructor, right? What this one is it's saying, okay, we're on the client side now. The argument that's going to be passed to me is a URL that I'm going to send a WebSocket request to, or a request like do an HTTP upgrade, which is what we saw in the earlier slide. Right. So now we're looking at client code. So at the first line, we have var socket is equal to IO of some URL, which basically specifies, okay, I want to connect to this server over a WebSocket connection. Then we start registering basically event listeners. So every time we send a quote unquote message, we'll call it emitting an event. Okay, that's kind of the lingo we're going to use. So anytime we emit an event, there's two things that are emitted. There's the event name, and then there's a payload. Right, because clients might be sending events for different reasons, which is why we need an event name to distinguish what the payload actually means. So for example, right, let's say a new message has been added to our chat server, right? Then it could be new message added, and then we assume on the server side, based on the way we've set up our event name, comma, whatever we're supposed to expect for payload. Then we can expect perhaps a string here, or maybe new user has joined the chat room, and then maybe that user's name or the username, and then we have to tell everyone who's connected to the chat room that someone is connected. Does that kind of make sense? So when we emit events, we emit two things: an event name and a payload. So now, in order to listen for events, so perhaps. So when we connect to the server, when a socket connects to the socket server, there is implicitly an event that is emitted back to the client that says connect. Connect is the event name. So now we're just saying, okay, on the client side, when we hear an event name connect, let's execute this function. This function is basically saying that we have connected to the central socket server. Does that make sense? So similarly, when a disconnect has occurred, so either the client side disconnects or the server side disconnects, then we're going to get a disconnect event emitted, and then we just basically log this statement. Make sense so far? Okay. What we can also do is emit events with the emit function. So socket.emit event name, comma, payload. So on the client side, we have the top block of code. What this is going to do is emit an event with type event name message and the payload hello world to the server. On the server side, when we execute this block of code, what's going to happen is that on line 1, it's socket is equal to IO, and we go ahead and emit a connection or try to initiate a connection with the server. The server says, okay, cool, I got a connection. I'm going to register this event handler on the server side. Now notice, this is on the server side, which basically says when I get an event with event name message on the server side from this socket, from the socket that's just connected to me, then execute this function. So what we're doing in this block under connection is registering a bunch of event listeners. Does that make sense? Per each socket that connects to us. Okay. So what's going to happen here is basically we're going to get a console log of hello world. And from the server side, we can also emit to particular sockets. So in this scenario, what's happening is once a socket connects, once a client connects to our server over WebSockets, we enter this function block because the connection has occurred, and then we can emit a message to that specific client saying like hello world, or rather it should probably be like a welcome message, like welcome to my like WebSocket server. Basically an acknowledgement that we've connected. What we can also do is emit events to every connected client, right? So for example, in our chat room example, when a client connects, we want to tell everyone that a new user has joined the chat room. We can do that with the socket server.emit event. Right? So what do we just talk about? We can emit messages from two specific sockets. Okay, so we can emit events to specific clients, which is what's happening in the top block, to every client from the socket server, which is on the bottom block, or we can emit events to the server as a client. Clear? Okay, cool. Broadcasting is a special way of emitting. It's not like it's kind of useful in the sense that socket.broadcast.emit basically means emit this event to every connected client except the one that is this socket. So basically, when you connect to the server, right? Let's say you connect to a chat room, everyone else should see that you have joined, but obviously you know that you've joined, so you don't need to see that like message like come up in your chat queue. You see, like that's like where the use case of this is like makes sense. Or if you're making like a real-time drawing application, like and you draw, actually that's kind of complicated. Let's not talk about that. Okay, any questions here so far? Can everyone parse this code and understand what's happening?
Wait, so for the event name of the like emit then event name and payload, like at the start it doesn't do anything, but then you have to like add the function, or like this update do something different to message.
It's up to you. So you can actually decide whatever event names that you want to send. The only ones that are taken is connect, disconnect, and connected and connection.
Oh, okay.
Those are the only ones that are like kind of taken. I think disconnection might be one too, but I don't think so. Disconnect. It's just disconnect. Okay. Any other questions? Okay, cool. So namespaces basically allow you to separate out the connected clients into subrooms. So you can think of this as like chat rooms basically. So let's say like you have a chat room at like /CIS197 and then you have another chat room at CIS like 120. Like all the message that goes to CIS197 should stay within CIS197 like namespace. And all the messages that go to CIS120 should stay within like that namespace as well. So it's basically a way for you to, or like let's say, yeah, it's an interface for the developer to be able to separate out what events are being emitted from what clients. It's basically chat rooms. That's what it is. This allows you to make chat rooms. Does that make sense? Everyone knows what a chat room is? Oh, is that a homework assignment? It's been too long. Yeah, so the way we create a namespace is basically we first create our socket server, and then we just say, of like / whatever namespace. And what we can do is, as a client, is explicitly connect to a particular namespace. So I think the typical flow here is that a client will connect to your HTML web page, and then maybe they have like two buttons, right? One of which is like, I don't know, what are two? Like vegetarians and meat lovers, right? I don't know, typically they're not like friends. I don't know. So then if you click on one of these, it might like execute a block of code on the client side which says like, okay, client clicked on this one, which means they're only going to talk to like other vegetarians so they can like, cyclical bias. I don't know what it's called. It's confirmation. I'm a vegetarian, so I can make fun of it, I guess. I don't know. But that's basically like the use case of namespaces. Like that's kind of like what the flow would look like. Does that make sense? Okay. Now the Socket.io also has rooms. You're just gonna have to like look at the code for rooms. Personally, I prefer namespaces over rooms because it's extremely easy to separate out what events are coming from where. But I think rooms like have its own merit. But honestly, like you can just use either one. I'm not like I don't think there's like too much of a difference. Yeah. Yeah, I mean, so with rooms, you can explicitly tell. Okay, so if you see over here, I create a namespace called like my namespace, and basically on this namespace, whenever I hear a connection on it, I execute this function, which is essentially like IO or like this block of code, like on connection, the socket server on connection. We kind of have the same block of code, but for namespaces. So namespace.onConnection, we're going to run this like function, which basically also takes like socket as a parameter in that function. So sockets by themselves can explicitly join a namespace. So the client can choose which namespace it wants to join. But with rooms, on the server side, we can explicitly put a socket into a particular server room. That's the difference. It's a difference in where the control is. Like who has control over which like namespace or room that they want to join, or which chat room they want to join. That's like kind of the difference. Does that kind of make sense?
Yeah.
Also, like, actually, no, that's not true either. Yeah, and you can create both like socket rooms as well as namespaces like dynamically, right? We could just say like whenever we get a request for create new namespace, we can just execute this block of code within that request handler, right? And then here clearly we can like execute the creation of new rooms like quite easily. Does that make sense? Okay, cool. And the last slide before we just like do some like live programming is, yeah, see, I knew we were gonna end early today. This is basically like a cheat sheet that I think is like extremely useful when you're doing like even when I'm programming otherwise, like I always come back to this cheat sheet because it's pretty useful. So on the first line, just like recap, socket.emit message and then or event name and then the payload. So this line of code can be emitted either from the client side or the server side. If it's emitted from the client side, it's sending an event to the server with that payload. If it's emitted from the server side, then the server is basically emitting that event with that payload to a specific client. The second line says io.emit. IO, sometimes people call it socket server, sometimes people call it IO. I prefer to call it IO, but those are the same entities. IO.emit basically sends to every single client and is only available as a function on the server side. The third one, we went over that one. Now this one is like when you're using rooms, you can broadcast from your socket to every client that is in a particular room. That's not you. Does that make sense? Or like the socket server is going to broadcast to every client in a particular room that is not the socket that sent the initial event. That's what that means. Okay. And then you can probably parse out like the next couple. I feel like I don't have to explain too much of these. Does that make sense? Do these make sense? Yeah.
Yeah. For in, does the client have to be in the channel to in the room to receive?
Exactly. So you know in that previous slide where we had like socket.join right here. So basically, what is this one called? It's called game. So I would have to like explicitly make this socket join the game room,
right.
And then I can like send messages to that particular client, either via this. Oh, actually,
right, because it says in. So does that mean that the client needs to be in that room to, can say I'm outside the room, right?
You're not going to get messages to the room.
Okay.
Was that the question?
You're not going to get messages to. What do you mean?
Like, if you're not in the game room, you won't get any messages that are explicitly sent to the game room, which is what this
I'm
is.
saying if you use .in, and you're not in the room, right? Will the room receive the message as well as you since it's specified .in? But you're not.
No. IO is this. Are you talking about this line?
Yeah.
So this is saying IO, the server socket, basically looks in the game room and gets a list of all the sockets that are connected and are part of the game room, right? To only those sockets, I'm emitting this message or emitting this event.
Okay.
Does that answer your question, or am I missing
I
it?
think so.
Okay. I think another important thing is that a socket can join multiple rooms, but or like a client can join multiple rooms, but can only join one namespace. I haven't been able to think of too many instances where I'm going to be joining like multiple rooms. I guess if you're doing like Facebook, like individual like messenger messages, but I don't think that's how we designed this. Okay, cool. So let's just do some live programming. Any questions about sockets so far though? So like I just wanted to be like super clear on what is being sent from where. Yeah.
Well, what's the difference between 2 and in for the?
So two is a function that's available on socket objects or on socket.broadcast objects, but in is available only on IO.
But they basically do the same thing.
They do the same thing, yeah. Okay, cool. So let's like code, and let me just like kill all of this previous code. Actually, let's just do okay, cool. So we'll just like start from scratch, and then I'll just make this like larger. Okay, so we'll first start off with like the server code. Yeah.
So like, what's the advantage of sockets with the HTTP?
Yeah, so the advantage over sockets is that you have like bidirectional data flow, right? So in HTTP, we went over that if a server ever wants to send data to a client, it cannot do it out of its own volition. The client must first send a request to the server, then only the server send a response. In that response, like it can send whatever data it wants to. But it can't do that without a request being initially sent from the client. But let's say the client says, okay, I'm allowing you to send me data like whenever you want to. Like in that situation, like HTTP doesn't actually make sense. What we do instead is use this thing called WS, or the WebSocket protocol. And in that protocol, this kind of goes back to this image that we had over here, where the client first sends a request to the server. I exist. The server comes back and says, "Cool, I'm going to open a WebSocket connection with you," and the client is like fine with it. Then after that, the server can send messages to the client at any point in time. I think like the reason why like this is like best illustrated is in this like chat server example, in the sense that let's say like this client wants to send a message to this client. The only way for this client to do so in this scenario is to go through the server. So the client sends a request to the server. Let's say we're only using HTTP now. The client sends an HTTP request to the server with its like maybe it's like a get/new message, and then in the payload we're gonna have or post/new message with the payload of like the user ID or whatever. Then the server says, okay, cool, I have this message, but I can't send it to this client because that client hasn't explicitly requested. So in this model, the only way for this client to get messages is by continuously requesting and saying, do I have new messages, 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 and basically like a while loop with like a little like timeout in between. That's kind of stupid. That's like a lot of load on the server that's like unnecessary, right? It's like getting hundreds of requests. It could get like many requests per second that actually just don't ever need to be made, right? Because like there's like no data for this client. So instead what we do is we say, okay, let's open up a bidirectional channel between both of these so that when this server actually has a message for this client, it can actually push the data to this client.
So then in the case for like, say like any like chat or messaging, right? I guess you have to use a WebSocket because if you're actively replying to each other, like even when you're texting, so you see bubbles, right? Like when you're typing as well, that means the client's like sending stuff while you're typing, right? So
Exactly.
You have to be bidirectional. Okay.
Yeah. I don't know like how like peer-to-peer programming works with JavaScript yet. Like I'm trying to like look into that. So I think that's like another way that you could do like more like real-time stuff and open up like a bidirectional computer or bidirectional like connection with my machine and your machine. But this is like the way you do real-time with like a server intermediary. Okay. So first thing I need is a server that should be able to process like WebSocket requests, right? And we should all be familiar with the following code, right? So express, require, express, and then we make an app, which is just like executing express. And now traditionally we've been using like app.listen, but like I mentioned before, sockets, the socket.io package only operates over the underlying node server, right? So what we're going to need to do also is require HTTP, okay? And then what we do is we say, okay, like our server is going to be HTTP dot server, and then we can just put app in here. So app is essentially that request processor that we talked about earlier. Then what we can do is say server.listen, and then we can listen on a port like 3000, and we'll just have it listen, I guess. So if we run node server.js, oh, cannot find module express. So first, let's turn this into an npm project, right? So that I can start like adding to like my package.json, which is my list of dependencies. So this created a package.json. We see that there's no dependencies in here yet, but I need at least 2 dependencies. The first of which is express, and the second of which is socket.io. So we're going to go ahead and install those. Okay, right? So now we can see in our dependencies we have both of these, socket.io and express. So now if we run node.server.js, should work. Let's see. Okay, cool. Now our server is running. It's not able to process any requests yet, but let's go ahead and make that happen. So when a client requests for the / route, we should just send them like an HTML web page, which we don't have yet. So let's go ahead and do that. And we'll just make like a normal HTML document, real time. And let's say let's just build a chat server. I feel like that's, unless anyone has any better idea. Okay, down for anything. All right, and here we'll just say chat server, or welcome to 197 chat, right? And let's just make sure that we can actually even send this to the client. Baby steps. So app.get / recres, and then we'll just say res.send file, the current directory plus index.html. So that should be good. Yeah, sure. Is that good?
Yeah.
All right. And then, man, I wish I could put this bottom terminal on the right side.
Right click on terminal.
Right click on what?
The word terminal on right click. Move to.
Yo, that's sick.
Look at that last.
Nice. Okay. Extra credit. All right. So now I can run the server again. Kind of go over here. Let's just say I go to localhost, and we see that the HTML file is being served to me. Everything makes sense so far? Cool. Now what I need to do is make sure that I can actually listen for WebSocket requests as well. So let's go ahead and get IO, which is nothing but getting socket.io. And what we're going to do is we're going to say io. Oh man, what is the function again? Like create server. Okay, cool. Let's go through the process, right? So socket.io with express. Let's look up this and then go here. And then there should be something. Okay, let's do this one. And then oh, here it is. Okay. So require socket.io, and then we have to pass a server object as a parameter. So then we can just do this. Okay, and let's make sure this runs without any hitches. Cool. So we have we have the ability to accept like WebSocket connections now. Everything is good on this end. So now what we need to do is just set up like when a client connects, we need to run like the following function. Everyone's familiar with arrow notation now? Cool. So what we can do in this case is we'll just like log like socket connected, or I guess like client connected. Okay, and in this index.html we still don't have the ability to send any WebSocket requests or even connect to a WebSocket server. So what we're going to do now is actually pull in the socket.io client distribution so that we can have the ability to do that. So we'll just go here. cdnjs.com, pretend I'm coming here for the first time. Oh, I was looking for this package, and then I go ahead here, copy the script tag back here, and we can just paste in the script tag. Okay, and then now I actually have access to the IO constructor. So if we look at this and we refresh this page and look in the console. refresh the page, we'll see that this function is actually available to us, the IO function. Does everyone see why it's available to us? Or I guess I'll just explain real quick. So script tags are actually run in the order in which they appear on an HTML page. That's from like last lecture. So what happens now is we first run the first script tag, which basically pulls in the JavaScript file available from CDN.js' servers. Then it executes that JavaScript file. In that JavaScript file, it loads this variable called IO, or this function IO, into memory. And then in this script tag, we have access to the same like variable. We have access to the same scope as this script tag does. So we have access to that function that's been loaded into memory.
Can you just know that it saves to the variable IO?
Yeah. It's like part of the package. You just have to like read the docs. It's available in the docs. Cool. So now what we can do is we can say, client socket, and we can just say, or you know what? Let's just do this. So the socket, this is my client socket. Okay. I'm going to connect to http://localhost 3000. Okay. And now notice here that we should log client connected whenever a client does connect, right? So if I refresh this page, this line of code is going to get run, and we should see something output in the terminal. Everyone understands why that would happen? Okay. So I refresh the page, and we see that nothing happened. Is that because I added that after I restarted the server? Okay, there we go. People see what happened?
Why did client connect one?
All right, let's just do this. Oh, yeah. So basically, the client distribution says if I'm not able to, I'm going to keep retrying connecting to a server until I can. So I think one of the previous requests was okay, so basically if I kill this and I restart the server, we're going to see that no one connects. And then if I open this, it should connect once. The reason is like it'll keep connecting if it cannot connect to the server. So this first one was a request that was sent because it couldn't connect earlier, and then the second one was a request at fault. Okay.
So if you refresh the page, it'll break client.
Yep. Yeah, each time you refresh the page, it's basically like, it's as if you have a new client, actually. Yeah, so that actually means it's not based on IP address. So maybe you're right. I think it could be based on cookies. I don't know what the reasoning is. But basically, each time you connect, it is a new socket object that's on the server side. But you could, all right, forget it. I think it could be either one. So now what we can do is we can actually emit events both to the client as well as like from the server, right? So let's say like on connection, we know that the client is connected, but maybe we should send like some welcome message. So to the particular client that just connected, I'm going to send a welcome message with like the payload like welcome to the chat server. Okay? And now on the client side, I need to be able to listen for welcome messages that are going to be sent, or welcome events that are sent to me. So let's do this. Split down. Nope, that's the wrong thing. I think I can just do that, right? Okay, cool. What the fuck? Oh, I want to kill that one. I actually just don't have enough real estate for this. No, let's move this to the bottom. And then make this a lot smaller. And then clear this. Okay, cool. So now on the client side, I need to be able to listen to events of this type. So on the left-hand panel, I have server. On the right-hand panel, I have client, right? And actually, let's free up some more space. Yeah, collapse that. Okay, so here I'm just going to basically say socket.on welcome message. And I'm going to have like some sort of like message that's sent to me. I'm going to just like log out that message, right? Or maybe we can just alert it so a little bit more clear. Alert the message. Okay. So let's say I go ahead and restart my server. Server's running. I come here, I refresh the page. We see that welcome to the chat server has been alerted to the page. Make sense? Okay, cool. What we can also do is emit messages directly to the server as well. So we can actually say, even within here, we can say socket.emit, I don't know, yo, like the payload yo, and then over here, we can say when this socket sends me the event yo, I'm just basically going to console log like whatever payload it like provided. Make sense?
You just write, why can't you write just console log?
I mean, console log is just like a function. So I'm just passing a function here, and then underneath the hood, it's going to execute this function with a single parameter, which is the payload.
Yo, so yo
Yeah.
passes the console log.
Yeah. Right, so I'm going to refresh the page. Welcome to the chat server, and then we're going to see that. Oh, I didn't save this one. Okay. Okay. And that's not happening. Why is that not happening? Okay, yo came through. I don't know why. But okay. Do people see like what just happened? Okay. And this alerting is actually getting very irritating. So I'm just gonna change this to a log statement. Okay, so now we have the ability to emit events, listen for events on both the server and the client side. So we basically have everything we need to like create a chat server now. Right? Let's go ahead and do that. So let's say when a client connects, we want to send them a welcome message, right? So we already have that line. And we already have the ability to listen for that. But I think before that, we actually need a bit of machinery in that we first need the ability to have messages, and then we need the ability to input. So let's just say like message input, right? And then we need a way to like send it. So send message, and we're gonna say send message.
Wait, how did you do that thing where you just put a ID, like a CSS line?
Oh, yeah. So let's say like I want a button with the ID of like something, and then a class like bottle, and then another class of like chalk, and I hit tab, it just like does it.
This is built into VS Code.
Yeah.
That's sick.
Yeah. Makes things a lot easier.
Holy shit.
If you have an unhandled event name, will that cause issues, or will it just kind of like go unchecked?
So as a developer, you're actually responsible for keeping track of what event names are flying through your application. So if you have an unhandled event name, it's just gonna go like, it's just gonna be silent.
Okay, so it's not gonna shut down your connection. Right?
Oh no! I can emit whatever I want on the client side. So I can emit like whatever, but if the server's not listening for it, it's just nothing's gonna happen.
Also,
Yep.
for the send file, do you need to do like underscore direct name plus index.html? Can't you just do index.html?
So send file needs. I think send file needs an absolute path and not just like a relative path. I don't know. We could test it though. But the thing is, like, you're gonna run into issues like when you're deploying on Heroku if you're not using because the file path is gonna be different on Heroku. Like, you don't know what the absolute path is gonna look like, which is what Durnan kind of captures.
And why can't we use render?
Huh?
Why can't we use render?
Because we haven't explicitly set up a view engine, and so in order to use in like the homework assignment we use like EJS, or like you can also use handlebars. Those are two specific view engines. If you don't have a view engine, you have to send like files explicitly. Or I think like the default view engine would be index.html. Actually, I don't know. Let's just see. Let's see what happens if we do res.render. Okay, so you need an HTML view engine in order to render HTML. And let's test your relative path thing. Path must be absolute or specify the root. Okay, so that should answer your question, I think. And then here we just had, what do we have here? Dir name plus index.html, and make sure everything runs again, and we're good. Okay, cool. Oh yeah, so now we see this, right? And because this looks kind of gross, let's just pull in Bootstrap. And we'll just get this link tag and throw them in the head. Everyone see what just happened? I just got Bootstrap. So now if I refresh this page, it should look a little prettier. Okay, cool. Except this button needs to have class. BTN, actually BTN primary. Yeah, okay. Cool. So now we need to like set up some stuff like, okay, when I get a message event, like what am I supposed to do with it? Like when the button gets clicked, like what am I supposed to do with that event? We need to start handling these things on the client side. So let's kill the server for now. And what we're going to do here is we're going to set up some of the jQuery stuff. Oh, I need jQuery now. So let's go ahead and get jQuery. So I hope everyone's like picking up on like the development flow here, right? It's like I need a package, I go to cdn.js, I can get the package, I copy the script tag, I make sure it's above like lines of code in which that in the jQuery constructor is going to be used, and then I can go ahead and like use the jQuery constructor over here. Everyone like get the flow of events? Okay. That's like the whole point of live programming. So let's just say like the button is this one. What is it called? Send message, and then the input is what is it called? Message input, and then the what is the other one called? The messages. So let's just say like messages is messages. Is this jQuery code making sense to everyone? I'm sure Pokemon Map Builder should have hammered that in quite hard. Okay, good. Okay, so basically when, let's first say when I get a click event on the button, I'm gonna first want to see like what is like the message like value, which is basically just taking like whatever was from the input, and then I just want to set the value of the input to be the empty string, right? That's for sure. Then I want to send this message value to the server over WebSockets, which we can do in just a second. Or let's just say we do it now. We'll just do socket, and actually let's get rid of this garbage. And let's handle this a bit later. Okay, and so we can emit, let's just say like we're emitting a message event with the message value as a payload. Also notice that your payload doesn't have to be strings, it can be JavaScript objects. So what under the hood, it's going to stringify it and then send it over the network and then destringify it for you on the other end, which is super nice. Okay, so do people see what just happened? So basically, if I type something in input and I click on the button, we're first going to get whatever was in that input field, set the input field to the empty string, and then emit a message to the socket server with the event name message, which means on the socket server, we need to listen for the event name message. Otherwise, we're not going to be able to process it. So let's go ahead and do that real quick. So when I get the event name message, let's actually call it new message. It makes a little more sense. New message. Everyone see that? I had to change, in order to change the event name, I had to change it on both sides, the client side and the server side. Okay. New message, and then the message is going to be the payload, and then let's just like console log this message for now, restart the server, and see if this goes through. Any questions about what I did? Does anyone want me to repeat it? Just the flow? I know I talked a little fast in that section. Cool. So refresh the page, and I send like hello, send message, and over here I should see hello is outputted on the server side. Do we see how I just sent data to the server? Okay. So now what the server needs to do is say, okay, when I get a message, I need to send that message to everyone who's connected to the chat room, right? Anyone remember how I do that?
Well, wait.
Almost. io.emit. Just going to send it to everyone, and I'm going to have everyone handle it in the same way. So io.emit, new message received. Technically, I can emit new message as well, but it's just going to get a little confusing. So is it I before E?
Except after C, so it's E.
It's EI. Okay, cool. So, yeah.
So do you want to send it to everyone or everyone except the sender?
Like, ideally, we send it to everyone except the sender, but then we're going to have like client code that deals with that. So we can do that at the end. We can refactor it.
Yeah. Okay, you would use broadcast for that?
I would use broadcast for that, yeah. So there's two things I could do, right? Let's say like scenario one, we want to use broadcast. In this scenario, user clicks on the button, our client-side JavaScript code immediately adds it to the messages queue, and then sends an event to the server, who then broadcasts to everyone else, saying, okay, add this thing to your message queue.
Okay.
Scenario two, we want to just emit to everyone,
Yeah.
in the sense that click button, Message sends to server, server sends to everyone, everyone in the same uniform way adds the message to the messages queue.
Okay. Alright,
So that's the one, I'm following the second
second.
pattern, yeah. Okay, so now on the client side, we need to listen for this message. Make sense? So let's put the client over here. And so now at the top, I'll say socket.on new message came, and we get like the new message over here. What we're gonna do is create a new list element, new li, which is just gonna be like this, I think, right? And then we'll just say like this new li, let's set the text of it to be whatever this new message was. Okay, and then we're gonna go ahead and append that to, gotta define these boys up here. And then we're just gonna say messages dot append the new list element. Kind of from like last class, similar stuff going on. So let's just say like socket. Okay. Everyone see what's happening here? Okay. Node server.js. Okay, server's running. Go back here. So when I type in some message here and I click on the button, it's going to send an event to the server with the event name new message. Once it gets this, it's going to say, okay, cool, I got the payload in here. It's whatever the user typed in. I'm going to emit that to everyone that's connected, which in this case so far it's only one person or one client. Then when the client receives that event, which is this new message came event, it's going to go ahead and add that message to its own messages list. So when I click send, we should see that happens. That's what just happened. Okay, cool. So what's cool though is like, let's say I refresh this one and I open up a new one. So we see how there's let's do this. Right, and then make this, destroy this, and then do this. Right. So if I type in like hi here, we see that it's added to both connected clients. Opening up a new tab in the browser is essentially like a new client.
Talk to yourself.
I do talk to myself, and I also do this. All right, so okay, that's what just happened here. But now let's say like, okay, I can have multiple like connected clients, but like nobody knows like who's talking to who. Like I can say like hello over here, and it's unclear like what like these messages, like who has sent like what messages. Also, we have another problem in that if a new client joins, they don't get any of the previous messages, right? Huge issue. We have like no like notion of history. So we're just gonna like build that in like real quick. So first of all, what's really cool is that with socket.io, I can actually set properties on the socket objects that come in, and those are gonna be properties that are unique to that socket. So let's say, let's just make like, okay, so let's real quick, let's just make like a random name generator. So let's just say like this is a bunch of adjectives, and then we'll have a bunch of nouns. So adjectives, green, large, incredible, and just give me one more, I don't know, special. Nouns, some nouns, potato, tomato, avocado, All right, cool. And one more, pumpkin. It's October, very festive. Okay, and then let's just go ahead and make a function that's just like random name generator, right? And then we'll just say like the first name is just going to be, okay, so let's just take adjectives of math.floor of math.random multiplied by the length of the adjectives array, right? So we're just going to get a random element from the adjectives array, right? And then we're going to go ahead and do the same thing, call it last name, and then we're just going to have like nouns, and then we can just go ahead and return first name plus space plus last name, right? And what we can do here is we can actually set a name property in the socket object to be like whatever the output of the random name generator is, and that's going to persist for like any event that comes through. So now what we can do is instead of saying new message came and simply, providing the message, we can actually say socket.name like says this. Does that make sense? So now restart the server. Cool. Restart this. And actually, you know what? Let's say welcome to the chat server. Your name is and then we'll just start at socket.name. And then I think on our what is it? Index, yeah. And I think what happens on welcome message is it's nothing so far, but what we really should do. Oh, you know what we'll do? Let's abstract this into a function of its own. So we'll say function add message, and for some message value, and then we'll just have this function get handled like this. Does that make sense? What I just did, I just abstracted that function out. So that basically means I can say add message for the welcome message as well. So we're using some code, a little cleaner. So now when I refresh, welcome to the chat server, but it should say, no, it's set over here. I think I just need to restart the server. Oh, there you go. Your name is Green Potato, and this person's name is Special Pumpkin. So now when I send a message like, hey there, we'll see that the Green Potato has said something, and then here if I say just like, oh, okay, does everyone see what just happened? Like I'm able to uniquely identify like the sockets on like the server side, kind of uniquely. Also, there should be space after this. Oh, also cool little trick. String interpolation with ES6 is actually quite nice. So you can just use backticks, then this means like variable, says, and then I can just do variable. It's like a lot nicer than using like plus signs. It's just like syntax. So you do backticks and then $, open close brackets. I like this one a lot. Okay, so I refresh the page, same stuff happens, right? Now we still have like the last problem, which is basically when a new user joins, they don't get any of the previously sent messages, right? So what we need is like some notion of history. Like so, traditionally you'd probably have these stored in like a queue, like a really fast queue, like Redis or something. But in this case, we can just make an array on our server. So we'll just have like messages, and anytime we get a new message, we can just say like messages.push. Let's say like this is going to be called cons like MSG, and we're just going to push it right there. So now every time a new message comes in, we have it available in the history. Does that make sense? So first we emit a welcome message to the socket that has just connected on a new connection, and then what we should do is say, okay, for each message M, let's go ahead and emit new message to that particular socket with M as a value. Make sense? Okay, cool. So now if we restart the server, go over here, refresh the page, and I refresh this page. Oh, those are really similar names. Let's just, okay, Incredible Tomato, and I send hello here, and then hello there over here. We should see that a new client that connects should see 2 messages. And we see that they do not. Why not? Messages.push, MSG, set for each of the messages that are available. We're going to emit a new message. Oh, new message came. All right, that should be the event name. Let's redo this. Okay, so refresh this, kill that, say, okay, again, hello, and hello there. Oh, the names are so similar again. Okay, let's do it again. Okay, those are so different. Okay. Oh, but this, yeah, it illustrates that it worked. Okay, cool. Does everyone see that it worked? Like if I just do this and then you just get the history. Does that make sense? It worked. Okay. Cool. Any questions? about like the whole like flow of things. So okay, let me just like walk through this like one last time, and we'll call it a day, and then we can all like stretch or take a nap after that. So just like high level things that are, what is that?
Nitrogen tank. I'm
Yeah.
scared. There's like 3 in the hall.
That sounds close.
I don't know. Sounds like cleaners, maybe. So anyways, Express does not like implicitly work with Socket.io. You need to basically, Socket.io works with Node, Express works with Node. They don't like technically work together. So what we need to do is abstract out the server component from Express, and then initiate our WebSocket server with that server that's been abstracted out. So we have Express, we require HTTP, which is the underlying HTTP capabilities of Node.js. We provide that server that's created with the HTTP create server command, which is like provided by Node, to like the Socket.io. Then we basically provide a way for the HTML file to be like sent to the client, because that needs to happen. We kick off the server, then after that we got this like random name generator. But most importantly, down over here, what we have is a block of code that says, okay, when a new socket connects to our server, we need to execute the following block of code. First of all, we see that they've joined, so we'll emit like a welcome event, and then we're just going to emit like the rest of the messages that have been sent so far, or all the messages that have been sent so far. Then whenever this socket sends us a new message, we're going to go ahead and execute the following block of code, which basically emits that message to everyone else. On the client side, we have a bunch of like jQuery stuff, but basically it says, okay, when we hear like a welcome message, append it to our queue or to our list, and when we see a new message, append that message to our list as well. Whenever the user like clicks on a button, we're basically going to send whatever they sent back to the server, and then the server in turn is going to relay that to everyone else. Clear? Yeah.
Would we normally put all that code in a HTML file, or could we like take it to a JS file and like import it there somehow?
Yeah. So what you would do is actually this is good. So there's a few steps to this. So what I need to first do is like I'm gonna make like a directory that is gonna like contain like all static files on my server. Okay, we're gonna call it the public directory, and then under public we're gonna say like client.js is gonna be client code. Okay. What I can do now is actually take all of this code and put it under this like client.js file. Now this code is like outside. What I can do here is like, ideally what I should be able to do is run like client.js and grab all of the code from client.js. Now we need to like support this on our server side. So the way that we do that is through middleware. The middleware that we use is, so let's go up here. So we're going to say app.use express.static. So now we're explicitly setting a static directory. And I'll explain what that means in just a second. Oh, didn't I explain this last time? I might have. But I can do it again. So express.static, and we'll just do like the dir name, which is going to be public. So we're saying public is our static directory. Whenever we get a request, so let's say we get a get request to slash client.js, it's going to look within the public directory first and see, is there a file called client.js? If so, I'm going to res.send file that file back to the client. So now that we have this, I should be able to just run this as per usual. Make sense? That's how you abstract the code out of the HTML document. That's a really good question. Like this, you should actually never have code that's written like that in HTML. Except, well, yeah. If you want like really fast load times and you don't want like multiple requests to be sent. So Facebook actually loads like a ton of their code like in the client side, like in one HTML document.
So normally though, you extract all that JavaScript code out in the client.js and then
Yeah. So for like final projects or anything like that, like you'd want all the client code out. But so the nice thing now is that like you can actually have multiple client files and actually have like modular, like nicely separated code on the client side, as you would on the server side. Cool. Any other questions? That was a great question. All right, thanks for coming. I actually ended early today. Not really. That's crazy. Okay.